All right, 9.2 day 2 is more graphing. So these first few examples, vertical asymptote, what makes the denominator 0? X is equal to -3. Can't beat that. So there's a vertical asymptote here. Horizontal, this is in the form of x minus h and then plus k. So this is y is equal to 5. This is a horizontal asymptote at y is equal to 5 like this. And then you graph this using your calculator to see if it opens in pseudo quadrant 1 and 3 or pseudo quadrant 2 and 4. The domain in this case is going to be x is all real numbers except it can't be -3 because there's an asymptote there. And the range is y is all real numbers except 5 because there's an asymptote there. But everything else gets used. The calculator does all the work for you. So for full credit on these notes, make sure you do 1, 2, 3, and 4 by using your calculator. Hey, real quick, questions like number 2. This is the other form where, very quickly, the vertical asymptote would be -4x plus 5 is equal to 0. -4x equal to -5. So x is equal to +5/4. The horizontal asymptote is the ratio coefficient, so y is equal to +3/4. So when you graph this, something like that, 5/4 is a little bit more than 1. And then again, your calculator does the work for you. Domain, all real numbers, except the asymptote, 5/4, and y is all real numbers except 3/4, the other asymptote, little curly brackets, and yada yada yada. Yeah, so hook up 1, 2, 3, and 4. But what I want to talk about in this video are the word problems. Now, the real world scenarios. You and your friends are sponsoring a dinner. The cost of catering the dinner is $9.95 per person plus $18 delivery charge. Now, let's go back to Algebra 1 or even first semester. If I gave you a question like this, the question I would ask was, what is the total cost? So let's talk about that. The total cost would be, well, it's $9.95 per person, so 9.95x plus, and there's a $18 delivery charge, right? Algebra 1, that would be the first thing, is just the total costs. But this unit, everything has been where x has been in the denominator, right? Look up here in all these graphing problems. X was in the denominator. Even this one, x is in the denominator. So we're looking for something like that here. It says write a model that gives the average cost per person. Now let's think about what average means. Average means takes the total amount and divide by the number of entries, or in this case, number of people. So here the average is going to be the total cost, which is $9.95 x plus 18 divided by, well, how many people are going to this party? We don't know. So x. So we're going to divide it by x, which is the number of people that are going to this party. All right, so the next part, get out your calculator. I forgot to open mine, so this will buy you a minute. And we're going to graph this. Now, we might have to adjust the window. Think about it. If nobody comes to this party, how much is this going to cost us? Well, $18, right? So our -10 window is probably not going to work. But let's not get ahead of ourselves. Let's graph this here. As soon as this opens. Whenever you're ready, SmartView. Probably should have done this before I started recording, huh? Shoulda, woulda, coulda, and all that biz. Anyways. Alright, so we're at parentheses 9.95x plus 18 divided by x. And when we graph this, that's not really what I'm interested in. First of all, X is the number of people, right? X is the number of people. So am I interested in -2 people coming? No, that's a weird party if -2 people come. What is that? Ghosts show up to your party? I don't want that. That's weird. So we want this way. So we might need to adjust our window a little bit. Now, the negative numbers for X, I don't really care about, but I like to see the X's, so I'm going to put in -1. But our X max, how many people do you want to come to our party? Let's keep it a small party. Let's keep it like, I don't know, 15. The Y minimum, it's going to cost us money. It's not like we're going to make money. So -1 to... Now, like I said, even if nobody comes, the price is going to be $18. What if 2 people? Well, here's the thing. Instead of thinking like that, let's just throw in a 30, an arbitrary 30, and see what happens. Press graph, and hey, there it is. All right, so let's talk about this. If we were to graph this, the graph looks something like this. Now, here's the thing. This is a scenario where X is on top and bottom. This is much like number 4 in your graphs, where it's just a single fraction with X on top and X downstairs. Right? Single fraction, X on top and X downstairs. So that means the horizontal asymptote is going to be Y equals the ratio of coefficients. So here, this is 9.95 to 1. Right? Y is equal to 9.95 to 1. So there's a horizontal asymptote at Y is equal to 9.95. So this is our horizontal asymptote that this graph is approaching. And if you look at the calculator, it's going down, but then it kind of levels out a little bit. So let's think about why. Why is this graph coming down so quickly, and then it kind of slows down and skates along this graph? Well, that's what's happening in part C. Describe what happens to the average cost per person as the number increases. What happens if one person comes? If one person comes, our total is $9.95 plus the catering charge of this 18 is our catering charge, right? So they have to pay the whole thing. They have to pay about $28. All right, they got to pay $18 and then $10 for their meal. All right, what happens if 2 people come? Well, each one of them's got to pay $10 for their meal a piece, right? But then, if 2 of us are going to this party, and if we're splitting the charge, then 2 of us have got to split the $18. So now each one of us is paying about $19, right? Because we each got our $10 plate, and then we're splitting the $18 2 ways for $9. If 3 people come, we're splitting the delivery charge. I'm just going to go here. Each paying $10, but now our delivery charge is getting split up among 3 ways, so it's $6 a piece, so $16. What happens if 9 people show up? 10, and we each got to pay $2 for the delivery charge, so it's $12 a piece. So what happens? The average cost per person goes up. Or describe what happens to the average cost per person as the number increases. As more people come, the cost per person approaches how much money? It approaches $9.95. Think about it. If 18 people come, that means we each got to chip in $1 for the delivery charge. So our $10 becomes $11. What happens if 1,800 people come? We each got to, that's a big party, right? 1,800 people come, we each got to chip in a penny. As more and more people come, it's going to approach $9.95, but never quite pass it, right? Because everybody's still got to pay for each dinner. All right, so let's go on to number 2. S sub I in geometry. That was the sum of the interior angles. S sub I is equal to 180 times n minus 2. You probably remember that from last year. We'll write the model that gives the measure of each interior. That was called E sub I. And E sub I, as you might remember, was called the sum of the interior divided by the number of angles, or number of sides, which is the same thing as 180 times n minus 2 divided by n. All right, so here's the thing. Use your calculator. You're probably going to have to adjust your window a little bit because, I mean, look at the numbers, 180. I want you to graph it, and I want you to tell me what's going on. Think about what this problem is talking about, and we'll talk about this in class tomorrow. Smith out!